Well, I'm not real surprised. This temperature sensor measures the temperature of the air, so the computer knows how dense the air is, and then it knows how much fuel to add to it. So if this isn't working, you would have a rich mixture. You would fail your smog test.
Okay.
This one screws into the air cleaner or the intake manifold. Now, this type here usually just clips into a hole in the air cleaner. Okay. Whichever type you have, though, they're quite easy to test.
All right, we've got a 2-minute test, and what we're going to use is our digital voltometer again.
Why don't you go ahead and put that on the, about the 20K scale, while I connect the 2 leads of the ohmmeter to the 2 leads inside the sensor.
Okay, we'll get a reading going here. There we are. Okay, we've got our reading.
Now, the idea is to change the temperature of this sensor and then read the change on the meter. Okay. Your body temperature will do that, so as I touch that with my finger, the reading should start to change.
Yep, it's going down.
And then as I release it,
okay, we're going to watch to see it slowly come back up. Now, the change going back up is obviously going to be slower than on its way down, but it did start changing going back up.
Great.
So we know this one is okay.
It sure is. Now, there's another place that you can find this type of a temperature sensor, and that'll be inside of the mass airflow sensor. Okay. Now, some vehicles have this kind of a device to measure how much air goes into the engine, and inside of it is a temperature sensor, just like the one we just tested. It's kind of hard to get at it with the leads of your ohmmeter because we have a connection here with very small pins in it.
Okay.
This is my device that I use to test this whole mass airflow sensor, but if I plug that in, there are 2 terminals on here that will allow me to connect my ohmmeter just to the air temperature sensor part of it.
Okay.
So as I connect from here to here, once again, you should have a reading on the meter.
And we certainly do.
And as I put my finger on the temperature sensor, we got to get some sort of a reaction.
Yep, that's dropping down very rapidly.
Okay, same test as before. And then as I let it go, you may begin to see a change.
Yep, it's just starting to slowly go back up. Obviously, your temperature, again, going back up is going to be much slower than actually going down. Now, if you find that your air charge temperature sensor is okay and you still have that code 23, what you're going to want to do is refer to your emissions and diagnostics manual, find the chart for your code 23, and what you're again going to probably end up finding is either a wiring problem or a problem in a connector or the actual ECM itself.
In either case, a 2-minute test will find it pretty quick.
Let's look at how easy it is to test an air charge temperature sensor. Set the digital volt ohmmeter to the 20K scale and connect the 2 meter leads to the terminals of the sensor. Touch the tip of the sensor or breathe on it and note the changes on the meter. If no change is noted, the sensor must be replaced. If the sensor passes this test, locate and follow the proper diagnostic chart to pinpoint the fault.
To replace your air charge temperature sensor, the tools you will need include a standard or metric wrench set, a regular blade screwdriver, liquid pipe thread sealant, and the correct air charge temperature sensor for your vehicle. To prevent burns and make the job easier, always begin with a cool engine. The first step whenever working on the electrical system is to turn off all the accessories, including the ignition key. Then locate the air charge temperature sensor. On many vehicles, it will be located either in the intake manifold or in the air cleaner housing or air duct itself. In either location, it may be necessary to remove the air duct or air cleaner assembly in order to access the sensor. Once the air charge temperature sensor has been located, release the locking tab on the electrical connector and remove it from the sensor. Remove the old air charge temperature sensor from the vehicle. Compare the old sensor to the new one to be sure of correct replacement. Coat the new sensor's threads with a liquid pipe sealant to prevent air leaks. Install the new air charge temperature sensor and tighten it securely. Before reconnecting the electrical connector, inspect it for signs of corrosion or damage. Clean any corrosion and repair any damage found at this time. Reconnect the electrical connector to the new sensor and reinstall any components earlier removed. you're done.
To replace your air charge temperature sensor, do the following. Turn off all accessories, including the ignition switch. Locate the air charge temperature sensor on the engine. Disconnect the electrical connection from the sensor. Remove the old sensor from the vehicle. Compare the old and new sensors to ensure correct replacement. Apply a liquid thread sealant as needed and install the new sensor. Be careful not to over-tighten the new sensor if it is located in an aluminum intake manifold. Inspect, clean, and reconnect the electrical connector to the new sensor.
Well, Jim, we still got that same GM vehicle, late model, and now I've got a problem with it at idle. At idle, it seems to want to die on me once in a while, and also I've got that same periodic check engine light that's came back. What do you think?
Well, since you have a check engine light, you're going to have to pull the codes.
Which I've done, and when I did pull the codes, I came up with a code 34. When I went to the manual, code 34 told me MAF Sensor. MAF stands for Mass Airflow Sensor, and they're located in a readily accessible spot underneath the hood, right in the air cleaner housing. How's our 2-minute test?
Well, we do have a 2-minute test for the mass airflow sensor, and if you'd like to take and hold this and help me show everyone how it's connected up. This is our universal tester. Now, the first thing you'll notice is we don't have the 9-volt battery on here.
Okay.
I have it connected to a transformer which will supply us with 12 volts for our testing purposes. We could have hooked it to a car battery with the car battery jumper, but this was a little bit handier for our purposes today. The point to remember is that mass airflow sensors are not 9-volt devices, they're 12-volt devices, so don't use your 9-volt battery to try to run these things. That won't work.
Okay, how about our connections?
Well, the connections are, there's 3 terminals. The one over here on the left is positive, so that's where I've got the red one connected.
Okay.
The one way over on the right is negative, so that's ground. That's where the black one goes. And the center terminal is where the pulses come out of. So to that terminal, I have connected the clip for the LED and the clip for this meter, which we're going to put on the RPM scale.
Okay, 4-cylinder scale.
Right, the 4-cylinder scale. We need the tachometer to measure this because these produce a frequency. And the frequency can be measured with a tachometer for our purposes, and the 4-cylinder scale is the most accurate scale for this. Now, I'll hold this and call your attention to the lamp. It should be flickering right now.
It is.
Now, that flickering lamp shows us that this is producing a frequency or pulses, and at the same time we should be able to read them on the meter.
Yep, and we can.
Now, to test this, all I have to do is blow through it because this measures airflow. And of course, when I blow through it, I will increase the airflow, which should cause the lamp rate to increase, and you should get a different reading on the meter.
Okay.
So let's do it a couple of times. Let's watch the meter first as I blow through here.
All right. Way up. 165 counts, and now she's going back down to where it was originally.
Okay, let's watch the lamp.
Yep, the lamp speeds up so much that it actually almost looks like a dim lamp. Now it's back to its flickering.
Right, that high speed. In fact, it almost looks like it's on all the time, doesn't it? Because the frequency is so high and the lamp rate is so high. Now, at this point in time, you might think that this is a good part, but one of the things that mass airflow sensors have a habit of doing is coming apart inside, especially in the electronics portion of it.
Sure.
So if you'll take an object such as a screwdriver and tap on that, we should be able to see a change in the output if it's loose, if it's defective. Now, you can't do that with the lamp. You must do that with the meter.
Okay.
So observe the meter while I give it a tap.
Ooh, way up. Way down and way up.
So it's going to be varying all the time. The reason why this was running when we started the segment was to get it good and warm. If you suspect an intermittent problem with your mass airflow sensor, hook up your tools like we've done here and set it on the counter or just leave it on the